So let's look at some of the other code as well. The function update positions, we'll take a look at that. Looks for collision detection to determine whether the cannonball has collided with any of the other canvas's edges, with the blocker, or with a section of the target. Game development frameworks generally provide more sophisticated built-in collision. So we'll take a look at this again. Lines 171 through 173 change the blocker's position by multiplying blocker velocity by the amount of time that has passed since the last update and adding that value to the current XY coordinates. 176 to 178 do the same for the target. Okay. Does it go faster? If the blocker has collided with the top or bottom wall, its direction is reversed. We saw that code already. Multiplies it by -1. 185 and 186 perform the same check and adjustment for the target. Line 188 checks whether the cannonball is on the screen or not. See where it's on. We just saw that as well already. Function update positions. It gets collision condition detection. 4 conditions illustrating that if the cannonball has reached the blocker's distance from the left side of the screen, the cannonball has not yet passed the blocker. Part of the cannonball must be lower than the top of the blocker. Part of the cannonball must be higher than the bottom of the blocker. So it's got to be overlapping somehow. Function update positions, manual frame-by-frame animation, and simple collision. If these collisions are met, we played blocker hit sound. We saw all this code already. We remove the cannonball if it reaches any of the screen's edges. So one of the things you can do here, to try and see this here, not sure how, well, we've actually got the files, if anyone's interested in it. Let's see, let's look at, most of this is going to be in the JavaScript. Let's see if we can edit this in Notepad++. Okay, these are all the variables. Setup game. Reset elements. New game. Update. Okay, so update positions is really what plays the game. It goes through all the possibilities of what's been hit, if it's reached bottom or top, cannonballs on screen. It goes through all the logic of did it hit something, did it hit the blocker, did it hit the target, and all that logic there. Fire cannonball puts the cannonball on screen and sets up the velocity, increments shots fired, and plays the sound. And it should set the cannonball on screen to true. The line cannon looks like it's just yeah, it's just adjusting. Oh, it's aligning the cannon. This is what keeps making it move to different locations. Which I wasn't too crazy about. It moved it after it fired. And then just redraws the whole thing. If the cannon is just an arc going 360 degrees, that's all it is. Right, so this one here is drawing the targets, and depending upon the color, and then ending the game. So, I mean, you've got 400 so lines of JavaScript code to do that game. Not that complicated. Um, it's not a very advanced game or anything like that, but still, it's a game. It's a pretty cool game. The target hits. Right, so this kind of goes through a lot of what we already saw already. The click event on the cannon causes the calls function fire cannonball. So I guess I could have done that click event anywhere. Oh, I see. It's the mouse that controls the direction of them. Oh, isn't that cool? You learn something new every day. Well, this is easy. Or maybe not that easy. Okay, not that easy. Anyway, so at least I know what controls that direction. That's good to know. Okay, so this is the fire cannonball. We looked at this code already. This is again using calculations to set up x and y coordinates as well as velocity. And it plays the cannon sound. So the aligned cannon is actually points the cannon where my mouse is. So that's and then it fires the shot. Right, so we saw the aligned cannon code already. Click point, that's where my mouse is. So it's calculating where the cannon should get fired based on the X and Y position of my mouse. It's in the lower half. It's adjusted by math pi. And it also moves the cannon's barrel. So these are two different shapes. This is probably just a regular old rectangle, and this is a arc, just a 180-degree arc. So there's no images. The only external files are the wave files for the sound. That's it. Everything else is very, very standard. So what needs to be the draw method just redraws the entire screen, everything that's on it, wherever they should be. We went through that again already. The cannonball's on the screen. It figures out where it should be, draws an arc. That's all it is, and closes it. And it does similar things with the cannon barrel, which is going to be just a very simple. It's doing line methods, but basically it's going to be just a rect. And then for the base, it's doing it's actually doing a 360-degree turn, but you don't see the other half of it because it's off the canvas. The blocker, it's got to do that as well, and it's basically just drawing lines. Okay, and then for the target, it uses the for loop to go through it and determines if it's hit. So if it's not hit, then it's going to draw it there either in yellow or blue. If it is hit, then it's just going to simply ignore it. And then that's just an alert that the game is over. I don't know if this is in it. I couldn't find the save and restore. This is the drawer method. Context. Oh, I guess it's right in the context. Okay. To actually save the state. Oh, I see. These are just some examples of the different color rectangles and everything too. Most current browsers also support SVG, Scalable Vector Graphics, which offers a different approach to developing 2D graphics. Vector graphics are made of scalable geometric primitives such as line segments and arcs. SVG is XML based, so it uses a declarative approach. You say what you want to, and SVG builds it for you. With SVG, each separate part of your graphic becomes an object that can be manipulated through DOM. DOM manipulation of SVG can degrade performance, particularly for complex graphics. SVG graphics easily and accurately scale to larger, smaller drawing surfaces. The problem with XML is XML in general is pretty slow. SVG is more appropriate for accessibility applications for people with disabilities. It's easier, for example, so ADA compliance. JavaScript is very difficult for the ADA, the readers, for the blind, to really interpret, whereas XML is much easier. So that is true. But in general, I would prefer to go with JavaScript and the Canvas stuff. More convenient for cross-platform graphics. No, I don't know. You could. Almost all those devices understand HTML5 now. Okay, so you can look at some 3D stuff. There's websites on 3D and whatnot. If you want to look at it. Okay. Any questions? No questions. Okay. Well, if there's no questions, we'll end the webinar. That's about it, what I've got for tonight. Okay, good night, everyone. Yes. Let me try and get into there right now so I can get that added. Which one are we looking at specifically? Is it Lab 5 you're looking at? 6. Oh, Lab 5 and 6. Yeah, they should be there now. I just put them on.